Okay, so yesterday we were talking about the slope formula and how we find slope from a graph in between 2 points. We didn't get to the end of the lesson. We didn't get to do all the examples I was planning on doing. So I'll make a short video with these 4 examples right now. So if you want to pause the video here, try these 4 problems using the slope formula, which is the upper right corner. Y2 minus y1 over x2 minus x1. Pause the video, try these problems, and then I'll cut to me solving and explaining what's happening in these problems. Okay, example 1, -2, 3, and 5, -7. Those are our 2 points, and we're going to find the slope between them using our slope formula. Change in y over change in x, or y2 minus y1 over x2 minus x1. So first thing we're going to have to do is we're going to have to label these points. We need an x2 and a y2, and we need an x1 and y1. So first ordered pair, I'll just label it as x1, y1. Second ordered pair, x2, y2. So -2 is x1, 3 is y1, 5 is x2, and -7 is y2. Alright, and then just plug it into the formula and simplify. Okay, so we got m equals, and it's just subtraction and division from here. Y2 minus y1, -7 minus 3, over x2 minus x1, 5 minus -2. I'm going to be careful with the minus and negative. Okay. And whenever I have minus and negative, I like to put the negative integer in parentheses. Okay. When you subtract a negative, so on top you have a negative minus a positive. So -7 take away 3 more gives you -10 on top. On the bottom, remember when you're subtracting a negative, it's the same as addition. Sometimes I like to put a plus sign over that whole thing. So really, instead of 5 minus -2, you could think of it as 5 plus 2, which is 7. And then simplify your fraction if you can. This one we can't. So -10 over 7 is our slope. Now when you write slope, we always want to keep it as a fraction, because you need that rise over run component if you were graphing these. Okay, so you want the 2 numbers up there, top and bottom. Alright, example 2. And 2 more points. Just label them. x1, y1, x2, y2. So we're finding the slope between 10, 6, oops, this would be y1, 10, 6, and -4, -2. Okay. Now remember, slope formula is just change in y over change in x. What we label x1 and y1 and x2 and y2 is kind of arbitrary. It doesn't matter which one's which. So on this one, if you're thinking ahead a little bit, you can, decide one of these terms is all positive, with the other order pair is all negative. So it's kind of up to you. If you don't like subtracting a negative, then you could flip the order around. Okay, as long as you do the same thing on each. So this one, I actually don't mind it subtracting negatives because it's the same as addition, and I think addition is pretty easy. So on this one, I'm actually going to flip it around. I'm going to do y1 minus y2 first. Okay. Because again, you're going to get the same answer either way. So on this one, I'll do 6 minus -2, y1 minus y2. Now the only thing you have to be careful of, if you do y1 first on top, you have to do x1 first on the bottom. Okay, they have to match up. So 6 minus -2 on top, and then 10 minus -4 on the bottom. Now again, you could have done y2 minus y1. You would have had a negative minus a positive. Okay, it's up to you. Remember, minus a negative is the same as plus. So 6 plus 2, or 6 minus -2, is 8. And 10 minus -4, or 10 plus 4, is 14. So 8 over 14 is my slope. That is not in simplest form, though, because 8 and 14 are both even numbers. So to put it in simplest form, we'll divide 2 on each. That'll give us 4 on top and 7 on the bottom. So a slope of positive 4 over 7. Simplest form. So always simplify these. You will miss points. And then like everything in math, there are special cases. Example 3 and 4 are both kind of special cases. So in example 3, our 2 points are 1, 2 and -5, 2. Okay, so one thing you might notice is that our y values are both the same. Okay. Well, that doesn't matter. we could still label these points and still use the slope formula. But if you're thinking a little bit about what the slope formula is, remember the change in y over the change in x. Well, if our y values are the same, there is no change in y. Okay. So what's that going to mean for our formula? Well, let's see. Let's do y2 minus y1. Okay, that's 2 minus 2. x2 minus x1, that's going to be negative 5 minus 1. Okay. So when we evaluate this, we end up with, again, we said there's no change in y. So the change in y on top is just 0. 2 minus 2 is 0. And then on the bottom, it doesn't really matter because 0, it matters. Negative 5 minus 1 is negative 6. But 0 divided by anything is always going to be 0. So what does this mean? Well, we already talked about what a zero slope is. Zero slope is just a horizontal line. So these two ordered pairs are a horizontal line at the point, with the equation y equals 2. Okay. So it's a horizontal line, y equals 2. So anytime your y values are the same in two ordered pairs, you're going to have a slope of 0. Okay, it's just going to be a horizontal line. The second special case is finding the slope between 4, 5 and 4, 19. Okay, so this one, you notice that the x values are the same. So in this one, there's no change in x. What does that mean for our formula, though? Well, again, you label them and plug it in and see what happens. Got your x1 and y1, x2 and y2. Do 19 minus 5 on top, y2 minus y1. And then, like we said, there's no change in x. x2 minus x1, 4 minus 4. So our fraction here is 19 minus 5 is 14. 4 minus 4 is 0, because there's no change in the x value, which means when you're moving from one point to the next, you're not going over at all. Okay, you'd only be going up. Well, if you try and do 14 divided by 0 in your calculator, you would find an error message. You cannot do 14 divided by 0. You can't do anything divided by 0. So that means this is that fourth case of slope, which is undefined. So these ordered pairs represent a vertical line. And the equation for vertical lines is just x equals whatever the x value is. In this case, 4. X equals 4. Now there's kind of a shortcut. Again, I'm not a big fan of acronyms, but there are two acronyms that people use for horizontal and vertical lines. It's HOI and VUX. Okay, so if you know me, you know I don't really like acronyms for math, but if this helps you remember, that's great. Okay. So what does HOI mean? HOI means horizontal lines. Horizontal lines have 0 slopes and y values only. So it's just y equals a number. Alright, well, VUX, you could probably guess. VUX means horizontal lines, not horizontal, vertical lines with undefined slopes have x only. So x equals a number. Alright, but then that's just, if it helps you remember these, great. If not, the slope formula still works for these. You'll either get 0 over a number, which is always going to be 0, or you're going to get x or a number over 0, which is always going to be undefined. Alright, so those were the slope examples we didn't get to talk about yesterday. And hopefully you guys got those right.